Okay, greetings. Be sure to pick up the handout that tells them about Monday's notes, and I guess I'll wait until a few more people walk in before I remind you that the homework is due a week from today. But since you all did come on time, I want to show you something that I think is fun to start with. This is an example of a literary genre that I just wanted to give as a very good example of being in its form. So here's a little short story, and I was sitting in my office cleaning the debris out of my 38 and wondering where my next case was coming from. I like being a private eye, and even though once in a while I've had my gums massaged with an automobile jack, the sweet smell of greenbacks makes it all worth it. Now, doesn't that capture a certain style of writing about as optimally as possible? If you were told to write a Sam Spade type of mystery story, is there a better way of I mean, this is almost as good as Raymond Chandler, and the sweet smell of greenbacks makes it all worth it. Not to mention the dames, which are a minor preoccupation of mine that I rank just ahead of breathing. That's why when the door to my office swung open, a long-haired blonde named Heather Butkiss came striding in and told me she was a nudie model and needed my help. My salivary glands shifted into third. She wore a short skirt and tight sweater, and her figure described a set of parabolas that could cause cardiac arrest in a yak.
This is what you all.
Do you recognize the author yet? What can I do for you, sugar? I want you to find someone for me. Missing person? Have you tried the police? Not exactly, Mr. Lupowitz. Call me Kaiser, sugar. Oh, all right, so what's the scam? God, that's right. She wants you to find God for me, and so on. And this is a great short story. Oh, yeah. I've had some fruitcakes up in the office before, but when they're built like she was, you listened. This style is I just think it's a wonderful piece of writing. Let's see. I opened a deck of Luckies and a pack of gum and had one of each. What's this? Oh well. So anyway, it's a missing person case, and it actually comes up through the. Okay, this is by Woody Allen, but when I looked at it, it seemed to me, and if you close it again and try to and just try to reconstruct the first paragraph, or try to think of how you would do that again to make the, you always start out in the detective's office and he does something tough, but he talks a certain jargon and so on. But this seemed to me captured it more beautifully than anything. Now, in your term papers, I want you to have a genre in mind. I don't necessarily want it to be a detective story or anything like that. But the point is that there are many kind of recognizable writing patterns, and whichever one that you choose, you try to do a good job in that style. I'm not saying do on a term paper in such a style. It would be interesting to try to rewrite some of these math expositions in different ways, I guess. But have one in mind that you're trying to do well. And today I'm trying to talk about web as a genre, or computer programs explanation as a genre, and trying to see some of the characteristics that can improve that. Herb Wilf, who will be our guest speaker on Wednesday, said he wants to show you a example of doing one proof two ways. One, that would be to if you were describing it to specialists versus describing it to undergraduates, and how he would approach the same problem, two different forms. Okay. Boy, it's hot in here. I'm going to take my sweater off. Excuse me. Well, yeah, I got a computer science T-shirt on underneath this, if you want to see that. Didn't think I'd have to show this part. Well, we'll wait a few minutes and so. Okay. Now, well, I was sitting in my office, cleaning out the debris out of my 38. Okay. Now, let's see. Remember, then, homework is due a week from today. No excuses for late homework accepted. Please do your best on that. As you can plan that you're writing it for somebody who's at the level of a reader of a math journal, or you can pretend that you're writing it for an undergraduate or something like that. It depends on your own preference. But I would be very interested in seeing the best possible solution to that problem, because I plan to send the best ones to Gilman for his information at the and then we'll see. And so, don't let me down. All right. Okay. Now, about computer programming and exposing computer programs, there's also an aspect of using web that encourages you to write better programs that I wanted to mention. We have the program broken down into parts, and each part has a certain focus to them. Each module has a certain focus to it. Now, when I'm writing a computer program in ordinary language, Pascal, C, or something like that, and I try to make that program look like a program that I'm proud of, so that after the program is written, the program is sort of still supposed to please me in some way. I like to enjoy what I do. Funny thing. Now, a good style of programming, if I'm writing a program that's going to be used by a lot of people, is to have a lot of checking and recovery from errors that might be present in the input data. But that actually takes a large percentage of the code. I mean, people say that it should be at least 25% of a good piece of software is entirely devoted to recovery from errors made by the user and trying to give helpful messages and things like that. And the rest of it does the actual job of the program. But a lot of it is devoted to error recovery. Now, but on the other hand, when you're writing a program in an ordinary language, typically you come to a part where you want to write a little procedure, and the job of the procedure is to do some task about the data. I guess I won't be specific, I'll just be abstract. But this procedure is supposed to do something. On the other hand, the data could also be wrong. So if you do the kind of error correction that you really ought to do, it would turn out that you have this short procedure, and it has 15 lines of code about error correction, and it has one line of code that actually does the thing that's correct if the data is wrong. And somehow it looks like the whole purpose of this procedure is to give an error message, and psychologically that doesn't appear right in your code. You see this procedure sitting there, and it looks like it's giving an error message. So you find subtly, in order to make this procedure look correct, you're trying to shorten the code that does the error message as much as possible, and you don't really get very enthused about doing a very beautiful error recovery for the person, because that would make the program look wrong to you. Web changes this, because in web you write the procedure and in the module that you say what the procedure does, and then there's a little line in there that says check if the data is wrong, and that check is in some other module. But that doesn't take up much space, and so you can see, as you see the procedure in the web code, it looks like the procedure doing the right thing that it's supposed to do to the data. Well, then you get to this other module where you're actually checking the data for errors and make an error message. But now that's on another page, but that's in a place where your whole purpose of that page is to make the best error message you can. So you're encouraged, as you're writing that other module, to do your best job of error correction, and so it turns out that it looks good now to make a good error correction in your program, and therefore you make a better one. And I found that this is true to a very surprising extent. And comparing programs that I wrote before and after using the web system, and comparing also I have programs that were written by by some of the top system programmers at Xerox and so on I started out thinking they were great programs, and then I took the program afterward and put it into web, and I found that I would actually be doing better job of error recovery and correction because of this fact. Okay. Now here's a small example of that occurred in the program by the freshman here, where he has a little procedure called hex to int, and he's converting a hexadecimal, 2-digit hexadecimal number to an integer, and so he has, a single, 1 digit, 1 character, and so he is checking if it's if the character is larger than a capital A in ASCII code, then he checks if it's less than F, and then he gets he converts it. But otherwise, he has this char error. And then, if it's not a letter, then he looks between 0 or 9 and makes an error. Now, most freshmen giving him a programming assignment wouldn't have had that error detection in there. And you can char error. He could compress also into one macro, and and I suggested that he forgot to assign a value to this procedure in that case, so there's a small change there. But since he was the only student who looked for errors in the input data, I gave him credit for that, and that reminded me about another fact of web. Now, here's one by I think this man was a junior, and I found that his first job in web was quite easy to read, and I just so I didn't have as many comments about I had to change which to that and stuff, and I just have to do that. But and at the very beginning he had a comment called placed here because Tangle insists. He's commenting that he had to make a definition here before it was used, because Tangle, that's the web program. That comment was completely uncalled for to criticize web in a document like this. So much better to have a comment saying the total number of vertices and so on. Okay, you can get by with this now. Then he used lowercase letters for the names of sections, and I suggested uppercasing them and so on. And then here's a place where when he's referring to add the edge from A to B, you should use the same typographic style when you refer to a variable so in web you put vertical lines around something if you want it to be formatted as it would be in the middle of a program instead of in the middle of a sentence. And so that was a small typographic change. Here's a case where he said he has a statement: if C is unequal to D, then merge the components of A and B. And that was the wrong comment. I mean, he's really merging C and D instead, and A and B don't appear in the actual code. So a better title would be to have C and D in the title corresponding to the variables that are actually there. But it was pretty good. I think it was pretty good. Problem here was, okay, well, he had a very nice, but he immediately caught the idea of giving good comments at the beginning of his modules, explaining the intuition behind the steps instead of a play-by-play. So he says, so he gives an analogy between, I'm not going to go into the details of the algorithm, but he has a nice way of saying this. And now here he gets into, we can further flatten trees as follows, and by this time the reader knows what it means to be flattening a tree and why you want to flatten a tree and so on. Then he says, we accomplish this through the magic of tail recursion. And this would be, for certain readers, this would be an interesting comment. Tail recursion is a magical computer science technique that says that at the end of a recursive procedure, the last thing you do is call the procedure again, and so the procedure reduces to itself. And tail recursion is this case where at the tail end of your job you recurse. Well, but unfortunately this is not example of tail recursion. So the comment didn't reflect the algorithm. This is a recursive procedure. But the tail recursion is a specific kind of thing. Now I don't know. Maybe they teach tail recursion means something else at the Stanford undergrads. I don't know. Hope not. There's a non-recursive solution actually for this particular problem that would be better. But it would have been a nice comment if it had been correct. A small point here. He had read from his data file lat, and here his comment was read lat, and it would be better to be redundant there and say latitude, so you reinforce the idea that this is latitude, and then he's reading longitude. Secondly, and then also I would add the comment ignore rest of line, because there was more stuff on the line, and he's using a statement that does that. So the comment can be improved slightly, but pretty much he's got the. So most of these comments that I made there were twiddles, and so for his first program that was quite good. His second program I got a few months later, and I still had to change which to that a few times, but but he had a strange way of starting, though. It wasn't the best beginning. We will soon construct a graph out of the distances between 128 cities. The problem that he's working on was kind of interesting. We have data that comes out of a standard mileage guide that was published for the trucking industry in the 40s, and it's actually used for many years. They do it with computers now, but for many years people would look up in this book and they would find out how much, how far it is between city X and city Y, and that would be the basis, of your charge for the cost of shipping, and so all truckers had these books, and we made a database from this book by taking one-fourth of the data. We took 128 of the cities and all the distances between those cities and put them into a machine, and we were going to use this to solve traveling salesman problems and things like that. Now, strange thing is that we found the data was very flaky, and many cases where the things would be hundreds of miles off in this book, and so we wanted to figure out a way of making the fewest patches to the data that would still make it reasonable, and so this is what his program is trying to solve. So he talks about the triangle inequality, for example. Now, the distance from A to B is usually should be less than or equal the distance from A to C plus the distance from C to B, because why should it be 1,000 miles from one city to another if by going through another city you could do better? You could do it in 500 miles by going through city C. Of course, maybe city C is New York City, and you don't want to go through New York City. Maybe Manhattan Island is, it might be a shortcut for miles, but not from some other points of view. So we could realize a few violations of the triangle inequality like that. But we still wanted the data to satisfy the triangle inequality that we finally gave. So we were going to my idea in this whole project is to publish these data sets so that researchers at different institutions can compare their algorithms on combinatorial problems with using common data, and the only way to do that right now is on random data, which doesn't seem to reflect reality. So we wanted to use some real data for this purpose. Here's a man from OR department who agreed that this might be a useful thing. There's similar databases for linear programming problems and so on. That was some inspiration for this. Yes.
This brings up something I've kind of been wondering about in the course. I'd like to see a lot of examples of an algorithm running on some natural data, and how if you're presenting an algorithm and the data, how you can combine them in figures or whatever, so that people
to show the way an algorithm runs, or to show something.
Yeah, show how it acts on a certain set of data.
I'll try to remember to bring something like that in, because this doesn't. give much output. This is mostly, this is just how we massage things. Yeah. The best actually for that is algorithm animation, which is instead of giving a book, you give a cassette, and and they run it on a Macintosh or whatever, and you see the algorithm. I mean, there's the great advances in that are going on now. There's what's the name of the system that's supposedly coming out now? Frame or something? But people, it was what? No, that's a company. But there's also a piece of software that the guy from Brown is about to finish. Anyway, but it's something. Okay, there's some ways that I think Mac Pascal has some ways to sort of see the thing as it's running. I haven't experienced that myself, but Bob Sedgwick pioneered this in a course at Brown about 5 years ago, where he presented, I guess, 20 algorithms during the course of the quarter, and each one had a visual. You could actually, it was associated with a certain visual pattern, and you could watch different sorting algorithms behave, and you could just psych out the meaning of these much better than any other way. It was pretty exciting. Well, he gave the presentation here in a colloquium, but I don't know. I don't go to conferences. I'm sorry. It's too depressing. There's more work to do every time I go to a conference. I like to hide that fact from myself. No, conferences are usually good for most people. But I haven't. I hardly ever go. For conference presentations, well, like Scott Kim for his oral exam here, he made a video that was extremely successful of showing the a session, demonstrating his program with different inputs, and it was done well, and he got it together in a week, so it didn't take, it was something that possible. I've seen a few other things like this where somebody would do it with videotape recording this. But this algorithm animation, the reader can also experiment with it, and play with the thing once it's there. And so software is being developed now to make this easier. Well, it's Bob Sedgwick. However, he's now at Princeton, and he's the You could. I think he's chairman of the department at Princeton, computer science. But to do it in a book, in some kind of a frozen form, there are ways to do that I'd like to show you. And we can talk about maybe even doing better, but these have been the best I was able to think of years ago. Yeah. Okay. Now, so I don't know how to fix his opening paragraph real soon. We will soon construct a graph, but I guess I would just go back to the old cliches about the purpose of this program is to construct a graph or something like this. But after that he got going pretty well, and he had a nice choice of names here, villains he has in this, and he considers that parts of the data are shortcutters, and the people you're trying to find the most villainous parts of the data, and so I thought that maybe he had to use Roget's thesaurus or something, but finding the word villains had an advantage that a lot of the exposition later became easier because we have other words that go with villainy, and somehow when it's hypothetical villainy, it's always fun. If it's real villainy, it's pretty disorienting. But in something like this, it seems like fun and games. Okay. again, he's got to learn to go in. You know, he puts a lot of things in proper type here. The name, lat, long, and miles, or so on are in italics. But then every once in a while there was a and here's the distance between the nth and mth city is given by miles of AB, which is was a funny change. And why do people always give N and then M second? I don't know. How many times have you at a conference or heard a talk where somebody will say, and let N and M be the following variables or something like that? Why reverse alphabetical order? It seems to be, I don't know, somehow it throws my mind off the problem somehow. To think, why did he reverse the alphabetical order? Is there some reason for it? Okay. Look at that. Oh, like a tag. Integers, that, give. Good. Now, I used to do this all the time. I mean, if you look at anything that I wrote before 1978, there will be an average of 3 wicked witches per page. But I've gotten to be very much reactionary against it now. Here we see what happens if you can't really see it too well, but this is what happens if you type a double quote in your file. You get a closing quote instead of an opening quote, and so that's one little refinement for that. When you go to author prepared typesetting, you might have to realize that there's a difference between quote marks and let's see what happened. That's coming up later. So people aren't used to distinguishing between open quotes and closing quotes because they're used to using a typewriter where there was only one. And it seems a simple, if we'd always had a distinction, then there would be nothing to say about it. And I suppose a computer typesetting system could go even and odd in every, or look for a space before or something like that and judge. It's funny in Germany, this is the opening quote, and closing quote looks like the other one. I mean, they start their quote marks that they go down below. He's whatever here. And then the other quote goes this way afterwards. It's so they're just backward, and so there probably ought to be reflected by some by some functional thing instead of giving the quote. I mean, what do you type in a text file in order to get this? Which directional quotes do you do if you're going into German style? How do you get people who are keyboarding manuscripts in Germany to understand the American conventions? It's a problem. Here a comment. I just said nice. I wanted to say this was this is an example of a very nice understanding of how to present part of a web program. So I thought I'd show it to you here now. Geometrically, a great arc is simply an arc of a great circle. A great circle is formed by the intersection of a plane and a sphere when the plane passes through the center of the sphere. The equator is an example of a great circle. Computing great arc distances involves converting the appropriate longitudes and latitudes first to spherical coordinates, then to rectangular coordinates, then finding the angle between the position vectors for the two cities. This angle defines an arc on a great circle whose radius is that of the Earth. The length of the arc is simply the angle times the radius. And now he defines constants with symbolic names. So he has pi and radius. And then he has a function to compute great arc distances. Now we decided that would be one way to catch something that was definitely a blunder in the data. If the shortest distance from A to B is less than the distance on the Earth's surface, the shortest possible distance, then we know that we have a data error. What? There's another guy from Manhattan who keeps bringing these things up. There's these tunnels. In New York, I throw these stuff out. Okay, yeah. But in fact, the ratio of highway miles to great arc distances is usually at least a factor of 2. I mean, you know, these as the crow flies doesn't really go to correspond to the way you have to drive. But we using this idea, and I gave him some data to calibrate from latitude and longitude of points where I had maps of Yosemite and things like that, where it was pretty close, and they seemed to correspond. So even though the Earth isn't spherical, it was a good enough approximation. But anyway, but now he has a function then that computes the great arc distance between city 1 and city 2, and he declares variables which are motivated. There's the store of spherical coordinates, rectangular coordinates, position, angle, and then he has the body of the procedure: convert latitude and longitude to spherical coordinates, convert spherical coordinates to rectangular coordinates, compute the angle between the position vectors, and then set the great arc distance. So this was motivated well, I thought, and you can read this and understand the algorithm as well as anything, and you get to the other modules, and so he gets to the next module about converting to spherical coordinates, and so he defines what polar coordinates mean, and talk about the radius of the Earth. And so here's a formula for spherical coordinates that he quotes with a displayed formula and everything. It's nice to be able to do that in the middle of a computer program, it seems to me. And so it was I thought well defined. Okay. Well, now,
it's strange
question,
to me, though,
David?
Yeah, that all the variables are declared in a place where they're not used, and then they're used in a place where they're not declared. Like
yeah, you could have. You can do this. You know, this is something that's 3 adjacent modules, so you can easily remember. If it's a longer procedure, then I would have said here, I would have had say var, and then I would say local variables for great arc distance, and then on the next page where I needed phi 1 and phi 2, I would have said local variables for great arc distance, and I would introduce them there. And like let me show you an example. There's a long procedure in here for breaking paragraphs into lines, and so I have a procedure called line break, and in fact, I even start out and say line break is a rather lengthy procedure, sort of a small world unto itself. We must build it up little by little, somewhat more cautiously than we have done with the simpler procedures of TeX. Here's the general outline, and then I give the outline of the thing, which I had already had a whole page of motivation on the preceding page, you know. But anyway, so then here it is, the var, local variables for line breaking, and at the moment. This is actually a global variable, so at the moment I'm not using any of these local variables, and we're not getting into them until 862, which is quite a ways beyond here, and so here we now motivate some of the local variables that we'll be using a lot and didn't need them before, and then it says see also 893, so 893 is going to have further local variables that are used during the hyphenation algorithm that also go into the local variables for there. So it's possible to capture local variables for any routine in the middle, and this is, and how often did I do this in this program? So I got modules named local variables for different procedures
Does web just do effectively macro substitution? Is that how
That's it. Yeah. Macros, it just replaces macros, and that's a very powerful little thing. And the name of the macro, there's 2 kinds of macro replacement. One is with a long name like this, which sort of indicates psychologically that it's code. And then there's short macros, which are these little things like I showed you char error or something like that, which are done with a define. And those are small, like, I mean, here I define a whole bunch of opcodes used in the output file, and stuff like that. So there's different, and there's another kind of define that. Yeah, let me show you something. There's an interesting trick that the macros aren't real general. They only allow one parameter at the most. Like here, I can talk about the stop bit of something, and that's a certain field of a word, and so the most general macro I have has one single parameter in it, but that it's possible to do a surprising amount with single parameters, and I'll show you. Well, let me show you one of the ways that you can do this. Now, in a more general system, you would build in a more general macro capability. But I was able to get by with single macros by the following trick. Here, I'll talk about char depth, and I'll follow it by two parameters. And so char depth is a macro with one parameter, and then it ends with the call of char depth end, which will then pick up another macro, and will give the second parameter. So where do I use char depth? In an example, let's see. It's not used very. It's not used right close here. So let me find the use of it. Char depth. Char depth is 708, 709. Okay, so I would. Okay, like char info of G and Y. Char depth of G and HD. So G and HD are parameters. Char depth has one parameter G, but it ends with a call of char depth end, which picks up the second parameter HD. Okay, so I could get the effect of two parameters without still implementing this whole system in 2 months, which meant I didn't have to have a real complicated parser and something. The macro substitution was simpler. And the other trick is. Let's see, do all 6. Where is do all 6 defined here? I'm going to show you another case of a strange way of using single macros that made them powerful enough that I didn't need something else. Okay, 823. Oops. Here I have do all 6 with one parameter, and it expands into that parameter of 1, that parameter of 2, that parameter of 3. And now, so I'll put do all 6, and I'll put the name of another macro as the argument to do all 6. And then I'll call that other macro with 6 different arguments. So I'll be able to say, okay, so the use of do all 6 will come along soon. Where is it? Here, okay, set break width to background of a parameter it says break width of the parameter to background the parameter. Then I'll say do all 6 set width to background. Okay. See this call of do all 6 here? Set break width to background. So that means I'm setting break width 1 to background 1, break width 2 to background 2, and so on. So that was a shorthand based only on macros with one parameter, which seems to be a lot more general than you ordinarily can do with it. Cut off on that. So when a procedure is short, I think I think you can remember these. But certainly, if I were designing a program, this is the most significant defect in Pascal, and Wirth. When he designed Fortran, he was trying to compete. Pascal was trying to compete with Fortran, and he was trying to get the Fortran market. And his original design of Pascal, he didn't have recursion in it because he thought Fortran programs didn't care about it. But he wanted to have a cleaned-up version of Fortran, and he was making it look rather like Fortran at the beginning, and then he put in recursion at the last minute when he found out it came free. but this was, but anyway, he in his previous language, Algol W, which was used at Stanford for teaching introductory courses for many years, and was actually one of the nicest programming languages ever in the history of the world. Had a great debugging system and everything go with it. But there he allowed local variables to be declared in the middle of a block anywhere you wanted to. And for some reason he took that out. I suppose it's back in module again. But he now insists, that all the local variables be declared up front here, which is not, and that certainly conflicts with the way you would want to write a program in the web programming style. The best way would be to be able to declare them right there in the middle of the block where you're using them. And so I'm forced to do as well as I can with Pascal as the underlying language. With a better language, I would be able to have a better exposition in this style. Yeah.
Wasn't that done so compilation could be one pass?
Compilation is one pass. Yeah, he had the compiler written in its own language, and he wanted it to be. But you can still do it in one pass. It's just it made a symbol table algorithm easier. I mean, the algorithm he had for identifier lookup was he just wanted that to be a small number of lines of code. And then he went and added the with statement some years later, which made it all very hard. But you can't. It's easy to criticize the design after the fact, and so many things go into a programming language. As I was writing tech, I would learn new things about Pascal every few weeks, and you might have heard a scream coming from my office. You can't have an array of file names or something like this of files in standard Pascal. In some versions you could, and all this. So I was unable to. I was going to use it for a system program, but there were many things about it that were crying out that they were designed only for textbook short examples and not for system programming. But web helped to surmount these difficulties by having macros. I could get around the not having an array of files and things like that. Well. And when Worth designed another language, PL360, I'm running out of time. He designed a language which was a symbolic equivalent of the IBM 360 machine language, and that exercise taught him, things about the 360 architecture that would have been much better, because once you saw it in this higher level form. Well, the same thing happens when you look at something through the web form. You look at Pascal and you see deficiencies like this, and these have all been cleaned up in Ada. Ada is this subset of Ada is very well done. The Pascal subset of Ada gets rid of all the problems of Pascal. Okay, now an announcement from the other text has arrived in the bookstore. A handbook for scholars. 23 copies arrived yesterday, and so they're all there. You can go and get what? Joe, you said you went to...
I went to the bookstore yesterday, and they told me that they didn't have any on order.
They have 23 of them there now for CS209, and 15 more on order. So, they probably looked it up in their computer, and they probably asked for the wrong thing. Okay. Now, another quick thing about this program. Here is a case where I could, I liked his choice of word villains and so on, but here he has a variable called scan, and scan is a variable that's moving through, and it turned out that when you study this algorithm, you don't want a verb for the name of that variable, you want a noun, and so a word like place would have been better. Call it place is replaced, because you're moving to the next place, but scan is not, so somehow. When you choose the names of certain kind of variables, you want adjectives. Sometimes you want verbs. Sometimes you want nouns. But think of their function in there. One other little point was the remove all villains from miles. This is the name of something. We're doing a operation that removes villains, in whatever that means, and you have to assume that this loop does it. But now, then he ends that with something that moves his pointer to the next thing in the list, and this statement here, take my word for it, does not have anything to do with removing villains from miles. This is something that really should have been done in section 32 where this code is used. So when this Pascal code will execute correctly, but he's assuming that in section 32 his last statement is moving his pointer to the next thing as a hidden thing, and so in section 32 he's got these remove villains from miles, restore least edge or something like this, and then hiddenly, not being told here, also move your pointer to the next guy, which is that should have been kept out in the calling module for it makes a much cleaner logic. So that's the kind of thing that so truth in naming is worthwhile in this. Now the last one I want to show you is by someone who is a dual major in English and computer science. I hope this doesn't identify him too much, but it was the most literate first use of web that I had seen for sure, and he's working on another kind of data set which is based on the characters of which is the encounters between characters in novels, and this particular one was Anna Karenina, and he did two drafts of this. So after I marked this one up, he did another draft. I commented about these quote marks, and I thought my comment would be specifically, very very easy to understand. So I just circled them and said, fix these. And so what he did was, when he fixed them, he changed them into single quotes, both undirected. So he didn't understand what I meant. I wanted directional quotes there. Now he's used typewriter type well here. You see, he refers to the name of a file, and he's using it also to refer to the data inside the file, where we're talking about characters actually, this is not Anna Karenina. It's also used for other novels. This is Les Miserables. You can use accents when you're doing this and stuff. And I suggested here that this data would look a little better if you shifted it over and indented it, even though in the file it isn't indented. It would still look better, I think, indented. Now, but he has a nice way of presenting it at the beginning, you see, because he gives real data, and he talks about so you can understand the format. This is something that is a very clear way of saying what the input looks like, and that's really the main thing that you want to do in a lot of computer programs, is give a good characterization of the input to your program and a good characterization of the output from your program. That's a very important part of documentation. Seems obvious, but it's surprising how many times you see programs that don't go into much description. With typography, you can make that description very easy, very readable, and doesn't take much more time than what you were doing otherwise. Here's a suggestion I made for using Pascal in a high-level way of Pascal. Pascal will recognize a particular idiom, packed array of char with a certain 1 ... and then it will. That's the way you have to represent strings in Pascal. And so I suggested that he declare, and he adopted this in his file. You declare a macro says string type of something, packed array of char, and then everywhere in your program you want to put a string, and now you can call it string type of something, and so it looks more like Pascal should have been in the first place. Now he has a funny thing here which maybe it's a standard computer science, but maybe only the way they teach it at Stanford. He says he chooses the hash list to have cabooses, and then he says we choose the component list to have engines. And so there must be, I don't know if this is something that there's something about data list processing that they have it, but I didn't know what, I never heard of cabooses and engines before, but if it's a standard term that I'm not familiar with, let me know, and then I took it back, but he believed that there, and okay, now here again I'm just suggesting that you take these and make a module a module somewhere separate for this function. I did that a few times to break up a long piece of code. This was his first use of web, remember, and so here again he had a confusion that somebody else had where he didn't know between it and we. We'll process each line click by click, and at each character in each click, it will perform a lookup. You know, we got to be consistent there. So he must have fixed that up when he came up with his second draft. But this, but it's trivially fixed up. So I think we're beginning to repeat on the kinds of things that go into computer programs, and so maybe I've caught all the things here. Again, I said put a begin and an end. I talked about this on Wednesday. Take the begin and end, instead of putting them around the call, put them into the the begin should be here and the end should be here, and that works better. The other thing that I played around with back and forth as I was first programming was position of semicolons. Should I put the semicolon in the module, or should I put the semicolon in the call? Finally, I decided. It was definitely working out better that I almost always put the semicolon in the call. So I would leave the semicolon here, but the end would be at the end here. That didn't work when I had declarations, though, because if I had something like procedure declarations, then each one wanted its semicolon to be there so that I could concatenate many declarations together. So I had to have a dual convention for that. If I had a programming language, if I was able to design a programming language knowing that it would be used with a system like web, I'd be able to have punctuation conventions that would work better. Okay. Similarly, labels in Pascal. He insisted that labels be numeric and separated by commas. I could have had something that if he would allow separating them by semicolons, I could have allowed some way to build lists separated by semicolons. But he uses commas in one place, semicolons in another place, commas between constants. So those things meant that the high-level language wasn't able to take advantage. Okay? See you Monday.